Now let's see the full wave rectification. Here is the circuit. This is the bridge, rectifier bridge with 4 diodes. Now I am going to connect the dry cell, upward positive, downward negative. The current from upward shown in blue color. Observe the galvanometer clockwise. Current passing from D1 and passing from P, and the galvanometer indicates clockwise and current reaches the negative. Now I am turning the poles of the rails. Now I am changing the poles of the dry cell. Here the positive is downward, current from downward in yellow color, passing D2, again it passing from P and the galvanometer indicates clockwise. Current reaches D and passing from D4, galvanometer indicate anti-clockwise and the current reaches the negative. Now the battery, the dry cell changes time to time. Change the current upward and downward change. Now I am going to bring the alternate power supply, the dynamo. To indicate the alternate power supply, I have given the symbol here. Okay, let's observe. Observe the galvanometers carefully and we will draw the graph also. Okay, now the galvanometer 1 indicates clockwise and anti-clockwise, but the galvanometer 2 indicates the clockwise side only. You can observe the current flow. So we can draw the graph for this. Now the alternate current read by the galvanometer 1 represents this graph, and the rectified current from the galvanometer 2 represent that graph. This shows the full wave rectification. Now we have corrected the direction change by this bridge. Now there is another problem. We have one more problem here. The voltage variation. How to correct this voltage variation? We know. We connect the capacitor. After charging the capacitor, capacitor supplied a small current. Then when the current dropped down to 0 is avoided. Although there is a reduction in the current flow, the 0 situation is avoided. This can be shown in the graph like this. Now this is rectification with smoothing. Okay, now PN junction is over. Next, PNP junction.